And then share again. So again, chapter 1 or section 4.1 was all about like just distributions. 4.2 was binomial distributions. 4.3 is geometric distributions and Poisson distributions. All right, we all got to say it, right? Say like Poisson. 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 Yeah, it's like a croissant, right? It is. Poisson distribution. But the Poisson distribution is not actually on the AP test at all. It's just something that this book teaches us, and it would be like in a more advanced statistics class. So I'm not even going to teach that to you. If you guys want to know about it, you can come to me personally later, but I'm going to do my best not to like fill your heads with things that you don't need for the AP test. I'm going to just focus on the stuff that we do need. Okay. Mm-hmm. So you'll notice that in the 4.3 section, there's like in the book on the back side of this, I copied down like the difference between a binomial and a geometric, right? On the back of your note sheet. But see how in the book there's also a Poisson down there, but you don't need to know it. So I left it off. Poisson. All right. So almost as fun to say as an ogive, maybe more fun than an ogive. Okay. A geometric experiment has the following things. Okay. So a trial is repeated. Sharing my screen, correct? Okay. You just said, and you don't know. You don't know. Shrug that off. I said, yeah, I was like, am I sharing my screen? And Tanner in front of me is like, yeah, you are. She doesn't know. She has no idea. Yeah, you are. A trial is repeated, thank you, until a success occurs. So do you remember when we were doing binomials, it was like, we're going to do this 7 times, right? We've got 4 kittens. We've got 7 nights of Netflix. We've got, you know, like whatever. It was exact. We knew exactly how many that was happening. This is more like what you would do if you were like, let's see how many times it takes you to get a free throw in basketball, right? Like, let's just try it. So it could take somebody 25 times. It could take somebody once, right? Depends on the person. So there's no set number of trials. So that's a really obvious difference between binomial and geometric. The second thing is that trials are independent of each other. One trial shouldn't affect the other. Third thing is that the probability of success is the same for each trial. And so here, X, the random variable, represents when the first success happens. I keep forgetting about it. I keep forgetting that this is a thing at all. And then I like do this. I'm like, wow. Oh, right. Okay. P is your probability of success. Q is what? Come on, you already know. What is it?
What's a percentage?
Failure.
Failure. And X is when the first success happens. Okay. LeBron James makes a free throw shot. I don't know why I said show. Gotta redo these notes. Great. He makes a free throw show about 75% of the time. Find the probability that the first free throw shot he makes occurs on the 3rd or the 4th attempt. All right, let's think about it first. Do you think it's likely that the first one he successfully makes will be the 3rd one or the 4th one?
Maybe.
What do you think is most likely for him? He gets it right about 75% of the time. Do you think he's most likely going to get it right on his first shot or his second shot or his third shot or his fourth shot? Probably the first shot, right? I mean, like he's got a 75% chance of getting it right on the first shot. Now, this table is not like it only goes to a certain thing. I'm just putting in it up to the fourth attempt. And this time, do you remember how last time we had 0 as a choice? We don't really this time because it can't be his 0 try. You know what I mean? It's like his first try, his second try, his third try, his fourth try. And remember, this is the success that this is like his first success. Okay, so let's talk about the probability formula, which is ridiculously easy for this one. Okay, anybody want to guess? What are the chances that he gets it right on the first try? %75%, because it says he gets it right about 75% of the time, right? Okay, so the first chances he'd get it right on his first try is 75% chance. Now the second chance would be this. It means that he got it wrong once, right? And wrong is 25%, do you guys agree? Q, because if getting it right is 75%, then getting it wrong is 25%. You guys okay with that? So he got it wrong once and he got it right once. And we don't have to worry about, remember the other probability formula had like that combination in there? We don't have to worry about that because we know that the time he got it right was his last time. So right now in your calculator, all you have to do is take 25% times 75%. Okay, let's try again. How many times did he fail if his first time he gets it right is on his third try? How many times did he fail? Twice. So like if he shoots 3 times, right? He must have failed the first 2 times and then he gets it right the third time. So in your calculator, you're going to put in 25% to the power of 2 times 0.75. All right. Megan, tell me for this one. 25% chance for failure, right? If his first attempt that he was successful, how many times did he fail? 3, good. And he succeeded once. Okay, now this says find the probability that the first free throw shot he makes occurs on the third or the fourth attempt. What does or mean in probability again? Add and subtract the overlap. Can he get it right on his third attempt for the first time and his fourth attempt for the first time?
No.
No, there's no overlap. So you're just going to add these 2 numbers together. So the question is 0.0469 plus 0.0117, which is 0.0586. Okay, now I'm going to give a prize. I'm actually going to give an impressive prize. How about a fancy pet? For the person who can come up with the formula for this. And it's not that hard. So let me talk about it. You see how we did this, right? Think about it in P's and Q's, right? Which one's the P, which one's the Q? And this one was when we wanted, remember this was when X equaled 2, because we wanted you to fail once and win once. This one was X equals 3. We wanted you to fail twice and win once. This one was X equals 4. We wanted you to fail 3 times and win once. Okay, so the question is, what's the formula? So raise your hand digitally or raise your hand in person if you want to give it a shot. You can do it. Okay, Mitchell's got an idea, Caitlin's got an idea, Megan's got an idea, Tanner? Tanner doesn't want to risk it. Krista? No, thank you. Okay, so Caitlin is 1, Mitchell is 2, Megan's 3. Three.
So would it be just flip the P and Q around and have it be like 75 and then do it to whatever power, like before the third power? And then do that times 25%?
Okay, so let's do it nice and slow. So 25 is P or Q in this problem?
P.
Mm-mm.
It's Q.
Yeah, because remember, P is the success right here. Success rate. Okay, so let's just get it right here. So Q, how many times are you going to fail again? You said 1 less than whatever we're at. Is that right?
No, I just said that it was to the whatever power.
Right. So if we were on x equals 3, then it's 2, right? And if we're on x equals 4, then it's 3. So it looks like it's 1 less. So how can I write that? Q to the power of
N minus 1.
okay, so I would say x minus 1. Because we don't really have an n. We don't have a number of trials this time. X minus 1 is how many failures we have. And then we also multiply it by, what was 0.75 as far as letters again? P. And how many successes do we have? This, well, there's 3 here, but I mean, like for each one, it was 1 success, and it's always 1 success. So this is just times P, and that's it. That's the whole formula. Okay, awesome, Megan. Did you want one of these before?
Yeah.
Would you rather have animals
No.
instead? Oh, I like these.
Oh Lord, which one do I take? They're all like good, like
I
they
think so.
are all okay. Like I just want to make sure that they're like I like this orange one.
Here, try it out. See if it's dark enough for you.
Yep, good.
Nice. Awesome. Throw it in the treasure chest. How's it feel? Good. All right. I'm going to give a prize to the person who can get example 2 correct. And you just have to look back at the chart that was on number 1. Okay. And then we will move on to the homework. Congratulations, David. Do you want to, have you checked your answers for the stats thing already? The 16, 18, 20, the problems we added?
I did.
Okay, did you get it right?
Yes.
You understand the difference between continuous and discrete?
Yep.
Would you like to just get this benchmark out of the way?
Sure.
Nothing like, you know what's great after taking a calc test?
Stats.
A stats test. Whatever, you're capable. We all know it. The question is, are my extra tests? Do I have an extra one? You know, my arm hurting wouldn't be bad if it didn't surprise me every single time, every dang time. Like every time I reach for something, I'm like, what? Oh, every time. I'm gonna have to print one out. Wait. All right, there you go. Calculator. All that stuff. Notes, yep. Hey, Emily, how's she doing?
Yo,
All right.
She's good?
She said, all right, I guess.
Oh. Okay, maybe I'll talk to her in a minute. All right, so hands up if you want to do example 2. For an animal, of course, not a pen. That's not okay. I like how you're like, oh, well, so it's an animal.
Oh, I don't know if I did it.
What am I
right.
just gonna not take it?
I'm like pretty sure I did it right, but I don't know. Actually.
All right, I think I'm gonna make
No, I don't know if this is right. Well, I guess let's go bugs.
Bugs and bouncy balls, okay. And if somebody doesn't want a bug, they can have a bouncy ball. 1, 2, 3. I'm such a weird teacher, aren't
Oh,
I?
I'm just like so obsessed with animals. It's like sad. Every time we bring up animals, I'm just like, oh my god. Like, what am I gonna do with these animals in a year? Like,
You're gonna take them to college with you, and they're gonna be like your little like thing on your desk, and people will be like, "What's this?" And you'll be like, "None of your business."
This is my collection of animals.
It's my collection of animals for doing a good job in math class. Okay, just leave me alone.
Nobody's gonna want to like be my roommate or anything. Like, if
I think that no one's gonna care or notice, Megan. And if you end up with somebody in college who's like, I love your personality and you're a wonderful person, but then I saw that you had 10 plastic animals on your dresser, and I've decided I will never be friends with you. Get away from that person, Megan. They just dumped you over 10 plastic animals. This is the stupidest thing I've ever heard. All right. So Krista's number 1, Mitchell's 2, Caitlin's 3, Megan is 4, Tanner is not involved. Fine, Tanner. 4. Is it you again?
Oh,
A stinker.
okay.
Okay.
Well, I just added 1 and 2 up.
That's right.
Oh.
Which is point?
0.9375.
Yeah. Just add up the probability of 1 and 2, and that's it. Everybody good on this? Which of these animals do you want?
I don't want. I want.
You don't want a bug.
I want
After all of that, did you hear how she made like a big deal out of this? And
Well, I
then,
already took a bug and it's bigger than the rest of my animals. It's like this isn't right. Like this praying mantis cannot be bigger than my hippo.
okay, but look at that little fly though. I don't have them made yet. You're gonna have to wait a minute.
Oh, okay. I'm like,
You were ready. You were on top of it. All right, so the homework's on the other side. It is a pretty darn short assignment. It is only 5 questions. Everybody look at this really quick. I just put this on the back because it's in your book and I think it's worthwhile. It just tells you the differences between a binomial and geometric all in one spot. Okay? All right, when you've turned in your homework online, I will let you go. You've obviously already turned in your benchmark, so let me look at the other one. I'm gonna stop sharing so David doesn't have to listen to this anymore.